Natural disasters like earthquakes are responsible for several thousand deaths each year. Do you know how many earthquakes occur in a year? The National Earthquake Information Center estimates 20,000 of them. That is, more than 50 earthquakes occur globally in a day. Not only ground shaking claim lives and destroy buildings, but it leads to instigation of tsunamis, landslides, and avalanches, paralyzing human life to a much greater extent. So how do we deal with this ticking time bomb without knowing when, where, and how will it explode? What if we could predict them in advance, or how intense will they be? For that, we need to understand how these calamities occur. A step forward is to understand simple collapses as shown on the right. My PhD thesis focuses on the mechanical properties of granular systems. Sounds complicated? Well, not so much if you look at the bottom left. You probably had some food grains or pills in your breakfast, or you often come across rocks and sand on beaches of Singapore. These grain-like materials are typical examples of granular systems. But what is not typical is this column collapse. The fundamental question is, why did this column break? Suppose you have 1 kilo grains and you add it into a column. What reading do you expect from the weighing balance? According to a German physicist Janssen, it will be 0.5 kilo. Interesting that one adds grains, but its weight is not felt at the bottom. This happens because of the frictional forces that the wall exert on the grains. The arrows represent the direction of these forces. Due to friction, the grains form an arc with the wall, thus sustaining the grains above. When more grains are added, they are supported by the walls and weight is not felt at the bottom. The column above broke because it was manufactured on the assumption that only the base supports the weight, as in case of frictionless materials like liquids. But when grains were loaded into it, the walls were not strong enough to support, and boom, it collapsed. What we found is a reverse Janssen effect in narrow granular columns. That is, if we add 1 kilo grains in a column, surprisingly, the scale shows 1.5 kilo. It means walls besides supporting can also compress the grains. But as they say, success is the uncommon application of common knowledge. So let me focus on the application part. All countries at some point of time transport granular materials from one place to another. And with it comes the problem of accidental wastages like these collapses. Have you ever wondered how much energy we waste due to these collapses? A survey predicts that we waste about 40% of our power only due to these accidents. So not only these studies will help food, pharmaceutical, and semiconductor industries, which rely heavily on these materials, on a broader picture, our Earth is composed of granular materials as well. Studying such collapses and understanding forces and failures in these systems can provide a deeper insight into earthquakes and avalanches. Besides saving millions of dollars, we can save many innocent lives too. Thank you.